2/6 is multiplying and dividing rational expressions. So again, we know what rational expressions means, right? It means that we're going to have the x's on the top and the bottom, or variables on the top and the bottom, right? Or at least on the denominator. That will get me a rational. Multiplying and dividing is what we're going to do first, and then the next section, 2/7, we're going to do adding and subtracting. So we're going to do multiplying and dividing. Our instructions are simplify and state restrictions. You should always state restrictions. Even if the question doesn't ask you to, you should always state restrictions. Usually we remind you and say, hey, state restrictions, but I think some of your homework questions might just say simplify, but they assume you're going to also state restrictions, okay? Here I said always for the numerator and denominator of a divisor. I'll show you what that means in a second. Okay, I'll explain what that part means. So we're going to state restrictions and we're going to simplify. So first thing we want to do, same as what we did before in 2.4, was factor. So the first step here is going to be factor. Okay, the second step was do restrictions. And then the third step was going to be simplify. Okay, so we still want to factor, restrict, and simplify. So we're going to factor first. Some of the factoring I'm going to do is going to be a little bit faster. You need to be able to factor, right? It doesn't have to be quite as fast as me, but you have to be able to factor in a timely way. So here, as soon as I see two terms, I look to see if it's perfect squares. Perfect square, perfect square. There's a minus in between. So I know that's x minus 3, x plus 3, right? We want to be able to recognize these ones. The denominator, I see two terms, but they're not perfect. Plus, you should always, always look for common factors first. So let's do a 2, and then we're going to go x plus 2. Okay, and I know that when you're doing it, you might have to look a little bit longer than me, but we want to do enough of these that you get bored with factoring, right? So that's what we want to get to. I use this little time sign. I hate that time sign because it looks like my x's, so I make it a little bit smaller. You can use a dot if you want, but that's fine. Okay, don't get confused with x, though. It's not an x. Here, on the top, I got two terms there. I can right away see the common factor 14, right? So we want to take a 14 and then a y, and we're going to have left. So I took the 14 and the y away from both of those. I'm going to be left with an x and a 2, right? And the y comes out, and I'm left with that. Okay, keep going. Denominator here, I got two terms, but the first thing you always want to do is common factor. Oh, and nothing left here, right? There's nothing left to factor. Sometimes always look at your answer and go, wait, is there more I could take out? No. So then here, I've got xy cubed, 3y cubed. Oh, I can take out a common of y cubed. Okay, and then I have an x left and a 3. All right. So fully factored, everything fully factored. From this step, that's step 1, I want to restrict. I'm going to always restrict my denominator. So all that 2.6 did, 2.4 was this, right? We had one rational function here. We have 2. So we're going to restrict all the bottoms. So it's like a double question, right? So we got double question. So I want to restrict this whole denominator and this whole denominator. So both. So it's like a double question. So we're going to restrict, restrict, restrict. So again, usually we give you a bunch of space on the side, so hopefully you have enough room there, and we'll give you rough paper as well. So I'm going to do kind of a line here, and I'm going to do my rough over here with my restrictions, right? And if not, we always give you rough paper, so you can do it over here. So I'm going to do a line, and then I'm going to do some rough over here. So I'm going to grab these guys here. So from this first one, that's just a number. So we're looking at each factor. Factor, right? Multiplies, multiply, multiply, multiply. So each one of those factors needs to be restricted, each and every one of them. So 2, can I restrict 2? 2 do not equal 0. There's no variable, so I don't have to restrict that one. So remember I said in 2.4, I said only restrict the variable because I can't say 2 don't equal 0. 2 isn't 0, so that's okay. So if there's no variable, we leave it alone. Here, x plus 2 do not equal 0. Okay? Again, if you're getting faster, you're okay to go right to this. X do not equal -2. So that's 1. If you want, you can circle it or highlight it, something like that, and you can go, okay, I want to make sure I remember that guy. Okay? The next one, I'm going to take this factor. y cubed do not equal 0. Okay? Y cubed. That's the same thing as y times y times y. So each one of those factors, right? Do I need to list it each time? 1, 2, 3. Y don't equal 0, y don't equal 0, each one. You can also do the third root, but the same thing. So all of them are saying don't equal 0, each one of those factors. So all of these, you don't have to show all this. Just go, well, it's 3 times. I'm not going to say it 3 times, but y should not equal 0. That's my next one. So if you want, you can box it or go like this and say, okay, I'm going to get that one and that one. Okay? So that factor. And then here, the next one, okay, I'm going to do x plus 3, please do not equal 0. X do not equal negative 3. And look, I've got my 3 restrictions, and I'm going to take those and summarize them at the end. Okay, but I'm going to hang on to those for now. Yeah.
Do we need to show the
Nope, right, what have I said? You don't have to show the work. If you can do it in your head, then you can do it in your head. Just make sure you list it at the end. Yeah. So some people show the steps, some people don't. Yeah, up to you. Yeah. All right. So then that's what I'm thinking in my head. I come back over here, so I have my restrictions. And then over here, I'm going to simplify. So step 1, factor, know your restrictions. The reason why I say restrict before I simplify is because you're going to cross off. So either cross off not like, remember I said don't scratch it off because you can't read your own writing. Cross it off neatly and just make sure that you restrict. So see how this one, okay, we're looking up and down. So in 2-4, I was canceling numerator and denominator. You're actually allowed to cancel numerator and denominator. You know that time sign? I can just go right through it. That's a whole numerator times a whole denominator. It's actually one whole numerator with one whole denominator, isn't it? Right? Because that's time. So I can just make it a long time sign. So just the whole numerator. So that means any denominator here can cancel with the numerator here. So it's like one long line, and that means any numerator with any denominator pokes out a hole. So 1 with that one, so there's a hole there at x equals negative 3, right? Is there anything else? Yeah, this one too. So if you cancel neatly, you can still do your restrictions at the end, but you're not allowed to ignore those two because those two immediately are holes in my graph. So these guys here, they have to be listed in your restriction, even though they're canceled out, but they're holes in your graph. So you have to list it at the end and say, yeah, but I poked them out, okay? Then you write down what's left over, but I haven't finished simplifying. I need you to also to simplify. So look, those guys are the same, those guys are the same. See these monomials? The monomials can be canceled as well. So it's back to grade 9 where we were canceling only the monomials, right? So in grade 9, we only did monomials together. So if I gave you 14y over y cubed, can you cancel those? What can you cancel? And we did that. The y, and I would have 2 left, right? So we did that. So you're still allowed to cancel monomials. It doesn't have to just be the binomials. I have a 2 over here as well. So if I had the 14y and a 2, can I not cancel those ones there as well? Make it a 7. 2 goes into 14. So you are allowed to cancel all those monomials together. If that confuses you, you can write it again together and then cancel the monomials in another step. Some people go, I'm confused with doing both. So if you want to, you can put the 2y here and then cancel it in the next step. But if you can do it in one step, then it makes your life easier because you don't have to write as much. So picture the monomials and look here, these guys. Those monomials, that's actually 2y cubed and the 14y. So you go 2 goes into the 14 and makes it 7. And this y and the y, I have 2. And then now you write down what's left over. So you're going to go. Start with the monomial, so 7. Everything else is canceled, so I go x minus 3. Is that gone? Yep, because the 2 went into the 14, gone. And I have a y squared left. Comma, x cannot equal negative 2 or negative 3, and y cannot equal 0. Separate statements. Yes? The 7 is from the 2 and the 14y and the y cubed. I'm actually going to grab that over here. Watch. So if I grab the monomials and I rewrite it, 14y, and I put the 2 with the y squared, right? So the 2 is with that monomial here. So you can clean it up one time first and then cancel again in another step. So 14y is the monomial. 2y cubed is the monomials on the bottom. And then you can go like this. 2 goes into 14, 2 into 14, so I get 7, a whole 7. And this y, I get 2 left on the bottom. So I get 7y squared. That's 7y squared. Yeah. So if you want to, grab it on the side, or you can simplify one time and do the monomials in a separate step. Right? Some people go, the monomials is what throws you off, right? Because you're getting the binomials in your head and you forget the monomials. So put the monomial separate and then cancel it again. You might have to do one more step, but look for the monomials, please. Okay, that seems to be where people always forget. You're concentrating on the new material, and then you forget what we used to do right before, because it looks different, a little different, right? But you used to do monomials all the time. Does that make sense? Okay, any other? And try it again. Try it again. Okay. Step 1. Step 1 is factor. So we're going to do step 1 is factor. So we're going to do this. Top and bottom. This is the easy factoring because it's a 1. So it's going to be multiplies to 4, adds to -4. So we're doing x minus 2. Do you want to do squared or 2 brackets? It's up to you. It's a middle step. Yeah. Sorry. All the way up. Is that okay if I move all the way up? Okay, we're all done that question. Sorry?
Maybe just zoom in.
I am zoomed in though. Right? It's just at the bottom because she's sitting at the back, so that it's at the bottom of the screen, right? It's at the bottom of the screen. That's why, right? Yeah, it's zoomed in enough. Yeah. Okay. And then you can either do 2 brackets or squared. Up to you. It means the same thing. Do you want to do 2 brackets or squared? Squared. Okay. Right. So either way you write, it's fine. Just there's 2 of them. And then here, common factor 2, and you got x plus 2. Is that all right? Okay. This one is division. Okay. Okay, and we're going to go x multiplies to -2, adds to -1, so it'll be -2 and x plus 1. So I know this might take you a little longer on the side. You're going to go, oh, I have to factor that, and come back. Okay, I'm just going through that a little faster. And when you're doing the homework, you're practicing your factoring as you're doing this. And I'm giving you a mark per factor, right? So this is going to be 1, 2, 3, 4 marks just to factor it. Okay, so 4x. Okay, and then we're going to go x plus 2 like that. Okay, so each one of these usually approximately is 1 mark. 1, 2, 3, 4. So we go 4 marks just for factoring. Haven't even done the simplification yet. Step 1 is factor. Okay, so factoring is good. We want to be able to factor, so common factors, stuff like that. Okay, so now we want to do restrictions. So for the restrictions, again, you can pull it to the side. Okay, some people don't show this. That's fine. It's up to you. Okay, I'm going to grab each one of the factors. So 2. Can I restrict 2? No, there's no variable. X plus 2? Yep. 1 second. Yeah, 1 second. 1 second. Yeah, I'll explain that in a second. Yeah, for the division, just wait. Okay. Here, x plus 2. Okay. So x plus 2 cannot equal 0. So x cannot equal -2. Okay. Here, the denominator here, you got this one and this one. 4x. Right. So again, grab it. Just make sure you know all your restrictions. Right. We don't want to waste them. Okay. So 4x cannot equal 0. How do you get rid of the 4? Divide both sides by 4. Good. Okay, divide by 4. So x cannot equal 0. There's my other restriction. How about this one? I did it already. So don't do it again. Right? We already did that one. So we got that one covered. Don't repeat yourself. Okay, so those are all the denominators. Now, when you divide, okay, this was multiplication up there. When you divide, you change this to multiplication. change this to multiplication and then reciprocal, right? So then this flips around. So change it, when we did fractions, you change it to multiplication and flip it around. So we're going to go, the numerator goes down here, x minus 2, x plus 1. Okay? This flips up, 4x and x plus 2. Does that make sense? So division becomes multiplication and you do the reciprocal. Could you have done that on the first step? Sure. You can do that right away if you see that division's multiplication and do that right away. Now, let's talk restrictions. The restrictions I took from the numerator of the original question, right? Every numerator must be restricted. I got that. So this is my numerator from the original question. This has now moved up here, but this is now my numerator, denominator. I keep saying numerator. My denominator. So my denominator from my original question, my denominator here is flipped up, but this is now my denominator here. So which one do I restrict? The denominator from my original or the denominator from my new one?
I would guess and say the new one.
Trick question, both. Trick question, because it was a numerator. You can't deny it was a numerator. So you can't say, oh, it wasn't. It was. So in the original question, you must always denominator. I keep saying numerator. Denominator. It was a denominator in the original question. So you can't say division by 0 is allowed. No, I have to restrict my original question. Then when you flip it around, it's now my denominator for my new one. I have to restrict my new one. Which means, now think about it this way. When you divide, am I allowed to divide by 0? No. So the whole thing cannot equal 0, either top or bottom. So as soon as you see division, you need to restrict by everything. That's what this was saying. Always for numerator and denominator when a divisor. When you're dividing, you want to restrict the top and the bottom. So you look and you go, oh, I get a double. So as soon as you see division, maybe put a tiny star here to yourself and remember to restrict. Okay? And say, wait, division meant I had to restrict the top and the bottom. Okay? Just make sure you do a double check and go, wait, denominator, and then I need both. So check your bottom here. Ooh, I have to add more restrictions now. Sometimes it's a repeat and you go, oh, I already have it. But this one, I get 2 more restrictions, don't I? They're different. So when I mark it, I'm going to be looking for those extra restrictions. Okay, so then grab this one now, and you're going to go x minus 2 cannot equal 0. So x cannot equal 2. And then again, one more time. One more time. And we're going to go x plus 1 also cannot equal 0. X cannot equal negative 1. Is that repeat? No, no repeats. And I'll do all 4 of those restrictions at the end. Okay, so both the top and the bottom. You can't divide by a 0 at all. So numerator and denominator. So both. Okay, so that's why. So at the beginning, you could have changed it to multiplication, and you know that as soon as you see the division, you're restricting both. Okay, so we want to restrict both. Okay, both the numerator and denominator. So that's the trick with division. Other than that, now once you've changed it to multiplication, I imagine that this is now a full line, and now I can I can cancel numerators and denominators with each other. Right? So I'm going to cancel. What would I like to cancel? I would like to cancel x minus 2 with one of these guys. So cancel. So satisfying. One of those is gone. X plus 2 with this x plus 2. Can we try the monomials again? Okay. So if you want to, grab all of your monomials and pull them to the side. Right? I always say that, I don't know why, but you guys hate the monomials because it's mixed in with these guys. So if you want to, grab it to the side and grab your monomials from the top, 4x, monomials from the bottom, 2, and do that on the side. Sometimes that helps you just focus it and go, I got all my monomials, simplified it here, my monomials, grab them here, and then simplify it there. Okay, on the side, and then put it back at the end, right? Because sometimes you're just like, it's so spaced out, it feels weird. So that would cancel. This would be 2. So that's 2x on the top. Okay, you don't have to do that, but if it helps you, then know that you've got a 2x on the top. So my monomial's on the top. I've got that there. I have one of these brackets, x minus 2, right? So I already grabbed this and this is canceled. So I just made that 2 like that. So I did that on the side. Gone, gone. Oh, and x plus 1 on the bottom. That make sense? All right, so don't forget the monomial, comma. Oh, I got to list all my restrictions. I don't care about the order. I want to see the 4 restrictions. So x cannot equal -2, 0, 2. Oh, so I can do plus minus. If you want, you can do plus minus. Up to you. And then -1. Right? So if you do plus minus 2 or 0, yeah, that's fine. Good?